triangle relationships, we're going to talk today about perpendicular bisectors, right? In triangles. Now, we've kind of talked about perpendicular bisectors before and saying that a bisector, number one, splits something in half into two congruent parts, correct? Either it can be for a segment or an angle. And a perpendicular bisector does it in a way so it forms a right angle. Correct? All right. So, the perpendicular bisector theorem says if a point lies on a perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. Okay, so here is the segment AB, right? CD is a perpendicular line that goes through the point D to a point C that's not on that segment. So if CD is perpendicular to segment AB and it's bisecting that segment because this is making two congruent parts, then it must be that this point is equidistant. C is equidistant to A as it is to B. So that means these two segments are congruent. Okay? So therefore, AC is congruent to CB. So if I have a perpendicular bisector that bisects a segment into two congruent parts, then that point that's on that perpendicular bisector is equidistant from the two ends of the segment. All right, so then we also have a converse theorem to the perpendicular bisector theorem. Remember what a converse theorem does? It swaps the order of the hypothesis and the conclusion. Some of us are going to be sitting by ourselves. All right, if a point is equidistant to two endpoints of a segment, so look, these are marked congruent, so B is the same distance to C as A is to C, then it is on the perpendicular bisector of the segment. So that makes this a perpendicular line, and it makes these two segments congruent to each other. Are with me? So if A and C, or AC is congruent to CB, and CD is perpendicular to segment AB, then segment AD is congruent to segment DB. So if it's equidistant to the endpoints, then these two little segments are congruent, and this is a right angle. So basically, if these two segments are congruent, and that's a right angle, then these two segments are congruent. And if these two segments are congruent, then these two segments are congruent. Okay? Goes both ways. And I want a red pen, so give me a second. All right. Oblivious to the world. All right. I'm being facetious. Okay. So, find the value of x. So, this line, this segment right here is a perpendicular bisector. Would y'all agree? Because it's perpendicular to that segment and it breaks it into two congruent parts. So, it's a perpendicular bisector. So, that means that these two endpoints are equidistant to this extra point right here, which means these two segments are what? Congruent to each other. So, if I want to find x, how would I do that? Set them equal to each other. So 7x plus 24, equals 13x minus 48. So those two segments are congruent, so I can set them equal to each other to solve for x. So subtracting 7x on both sides, 24 equals 6x minus 48. Then I add 48 to both sides. What's 24 plus 48? 72 equals 6x. Divide by 6 and x equals 12. Now, that's all it said to do was solve for x, correct? If it wanted us to find one of the segments, we could, couldn't we? All right. So, number two is kind of going by the original theorem. That last one used the, no, this one is using the converse theorem, sorry. So this one, it has this segment with a perpendicular segment, and it has these two links to this external point here are congruent. So that means these are what? Yeah, these two are congruent if this is a perpendicular bisector, and these two are congruent. So that means I can do what to solve for x? Set them equal to each other. So 17x minus 3 equals 9x plus 13. Pretty equal. I mean, pretty easy. We're just setting a lot of things equal today, looks like. 17x minus 9x is 8x minus 3 equals 13. Add 3, 8x equals 16. Divide by 8, and x equals 2. Questions? Okay. So lots of segments congruent to each other. Let's do number 3. This one, we're going to have to find x, and then we're going to do what after we find x? Plug it in and get what? The length of RS. Okay. So first we have to do what to them? Set them equal to each other. So 7x minus 22 equals 4x plus 5. What is my pen doing? And then I subtract 4x. 7x minus 4x is 3x minus 22 equals 5. Add 22, 3x equals what? 27. Divide by 3, x equals 9. But I need to find the length of RS. So how do I do that? Yes. So RS is 4 times x plus 5. And I know that x is now 9. So 4 times 9 plus 5. What's 4 times 9? 36. Plus 5 is 41. So the length of RS is 41 units. All right. I want you guys to do problems 4, 5, and 6 on your own, and then check with a group. Y'all do 4, 5, and 6. So we're switching gears a little bit with today's notes. So far we've been solving quadratic, algebraic methods to solving quadratic. What we haven't talked about, the graphing aspects of quadratic equations and solving quadratics by graphing. So we're going to start today. We're not going to completely graph. We're just going to introduce the graph today and then actually graph them tomorrow. But today's lesson, y'all, is super important because you've got standards that say you got to know how to identify the maximum and the minimum of the quadratic. Okay, that's what we're doing today. Very important stuff for us. So make sure I know my notes don't look exactly like yours, but you should be able to pick up on what the field is. Yeah. All right, so the first thing, we have standard form of quadratic equations. Y equals ax squared plus bx plus c, where a cannot be 0. If a is 0, it's not quadratic. Okay, so that's why we specify that. So in other words, this would be a nice big box around this, and you put it in your notes, yeah? All right, so on the graphing part, we graph the quadratic equation created a U-shaped curve called a parabola. Say that word with me. Parabola. One more time. Parabola. Not parabola. Parabola.
Y'all said it too.
We can try and say parabola every time we say that, right? All right, parabola. The U-shaped graph called a parabola.
Which one, AJ? More guys. Thank you. Yeah, you put that on the Gary County Planning Board. All right. Okay, the next part.
All right, y'all check them with each other. Liz,
They do not have to be perfect. What we're getting the gist of today is if you see the idea of what the graph looks like. Tomorrow we'll get more exactly of it. Does that make sense? Okay, so everybody has to calculate. And you're gonna try to put not equal, but it's the top left hand button, and you can put your numbers like this. Okay, whatever time in, clear it out.
okay, so on number 4, I'm just gonna call out the answers. Is that okay with y'all? And y'all can check it. If we need to work it, we can do it. On number 4, what did you get for X? Yeah, I hope I'm on the right page. On number 4, y'all got 4 for X, and you plugged it in to get the length of EG, and what did you get? 19. Raise your hand if you got X is 4, and then the segment is 19. Do I need to work that one? Number 5, what did you get for X? 14, and you plug it in to find the segment AB, which is the whole thing. Did y'all see that? Yeah, what did y'all get for the whole segment? 118. So you plugged in one for one or the other and got 59, and then you double that. Right? Did anybody not get 118? So you actually have to read and see what segment you're trying to find. All right, so number 6, what did you get for X? 20, and what did you get for the length of JK? 94. X is 20 and JK is 94. So do I need to work any of those for anyone? All right, now flip to page 6, and we're going to talk about angle bisectors. So an angle bisector bisects an angle, correct? It splits an angle into 2 congruent parts. So if a point is on a bisector of an angle, so like in this picture, D is on the angle bisector A ray D, or ray AD, if you say it. Ray AD is an angle bisector because it's splitting that angle into 2 congruent smaller angles. Y'all see that? All right. Then it is equidistant from the sides of that angle. So the closest way to get to from one point to another is a perpendicular line. Do you know that? The closest way to get from one point to another is a perpendicular line. So if this angle is being split, then the length from this point D to point C is the same length as point D to point B. So basically, if the angles are congruent, then these 2 segments are congruent. If 2 angles are split in half, then those 2 segments are also congruent. So we would say segment BD is congruent to segment DC. Y'all with me? And the converse says, if a point is on the interior of an angle and is equidistant from the sides of the angle, then the point is on the angle bisector. So D here, it's showing is the same distance from D to B as it is from D to C. So that means this angle A must have been bisected. So that means this angle A is congruent to this angle A. So angle BAD, that's a bad angle, is congruent to angle what? DAC. Angle BAD is congruent to angle DAC. So if it's equidistant from both outside sides of the angle, then the angle is split into 2 congruent parts. It's bisected. If the angle is bisected, then it's equidistant to both sides. Basically, if these 2 angles are congruent, then these 2 segments are congruent. And if these 2 segments are congruent, then these 2 angles are congruent. Okay? So if you show that these are congruent, then these are congruent. If you show these are congruent, then these are congruent. So a lot of setting things equal to each other. So on number 1, I don't know why I have things circled, but number 1, how would you find the value of X? Well, on number 1, we have this angle is bisected. Y'all see that? Because this little angle is congruent to that. They each have one little tick mark. So what does that tell me about these two lengths of these segments? They're congruent, so I can do what with them? Set them equal to each other. So 4x plus 30 equals 9x minus 5. Subtract 4x. 30 equals 5x minus 5. Add 5. 35 equals 5x. Divide by 5 and x equals what? And it didn't say to find any lengths, did it? Okay. Number 2. Same thing. This time they tell you that these points are equidistant, which means they're congruent. So what does it say about this angle? They're congruent because that is an angle bisector, right? So that means to find the angle measures, I set 5x minus 11 equal to 8x minus 41. So subtract 5x. Negative 11 equals 3x minus 41. Add 41. What do I get when I add 41 to both sides? 30 equals 3x. Divide by 3 and x equals 10, right? Now, it did not say to find the angle measures, but could we if we wanted to? Yes, and when you do that, if you're finding angle measures, you put what units on your angle measures? A degree symbol. Okay, so let's just do number 4 together.
Back up, yeah? So this point right here, this is the vertex.
So on number 4, I don't know why I said 40. It has these two segments are congruent right here. That's equidistant from this point on this ray to point Z. So what does it tell me about these two angle measures? They're congruent because ray W or segment WZ is an angle bisector, correct? So set them equal to each other. 8x minus 32 equals 3x plus 3. And then I'm going to subtract 3x to get my x's together. So 5x minus 32 equals 3. Add 32 on both sides, and I have 5x equals, I don't know why it's erasing some of my stuff. 35, divide by 5, and x equals 7. But I want to find the measure of angle XWZ. Now, you got to be careful. What if they wanted me to find XWY instead? How could I do that?
You could figure out one of them and double it.
Yeah, I can figure out one and double it. So make sure you actually look at the vertices of what it's trying to get you to find. Does that make sense? All right. So XWZ is going to be the 8x minus 32, right? So the measure of angle XWZ is 8 times 7 minus 32. What's 8 times 7? 56 minus 32 is 24 what? Degrees. What is the measure of angle YWX? 48. You double it. Okay? Any questions about that? I want y'all to do 4, 5, and 6. Or 3, 5, and 6. Y'all try 3, 5, and 6. If you work ahead on your practice, you're going to get a book assignment to go with it.
There's a whole blue book under your desk. Lots of these questions.
Look at the best that work in that class. Y'all laugh to the
Let me know if you get stuck. So these you actually have to go back and find a missing segment or an angle.
So you want to look for we got it, okay? Yeah. Now, good. He's gonna miss work. With 80 minutes of time, it's pretty fun. or? And we ain't got time for that, because I didn't believe there was almost 4 or 5 nights in a row where I didn't give y'all new homework assignments, and then nobody came out and turned in and did some work.
We get done with this, remind me we got a bubble, okay?
Did you?
We gotta have a bubble party.
Okay. All right, let's define the vertex. So the vertex is a point. So it's the point where the parabola intersects the axis of symmetry. Like I said, I'm abbreviating that as AOS. Kristen, why are you not writing this down? Now, when I say point, by point we mean ordered pair. The vertex is an ordered pair. And we'll see in just a minute. We have to be very specific with the axis of symmetry and the vertex about how they are written. And we've already talked about this, and the vertex is the lowest point, it's called the minimum. So that's when A is positive. Okay, when A is positive, so we have a minimum. When the vertex is the highest point, it's called the maximum, and that's when A is negative. So make sure you pay attention and have those two situations memorized. Because they're quite easy to get mixed up. Because if you think of A being positive, you think of that being high, right? If you think positive, but it's actually not in this case. If A is positive, we're going to have a minimum, and if A is negative, we have a maximum. So be very careful with that. All right, everybody good on this one? Okay, let's look at some examples. Find the AOS, vertex, minimum or maximum, then sketch each parabola. All right, so number one, we have y equals x squared plus 8x plus 15. Now, way back when we did quadratic formula, we identified, this was still on the front, we identified A, B, and C, yes? Okay, y'all tell me what A is to help us out in this version. A is 1. What is B? And what is C? Very good. Very good.
You can use all three of them. check
Now,
them
what did
out.
we say the formula for axis of symmetry was? X equals negative B over 2A. You have to have the X equals. If you don't, it's wrong. I know it's what somebody said, and then it's what somebody else did not say. I get that. I'm just making the point that we have to know it's X equals. Okay? So I did hear you. I know why that's funny, but I did hear you. All right, so when we plug these in, we're gonna have X equals negative 8 over 2 times 1. So we're gonna leave negative 8 alone, we need to simplify 2 times 1, it's 2 times 1. 2. And then how do we simplify negative 8 over 2? Negative 4. So our axis of symmetry
Do
is,
y'all just want to call out answers like we did last time? Okay, if there's one y'all need to see, just let me know and I'll be glad to. But let's just check number 3. On number 3, what did you get for x? X equals 3. What did you get for the length of AD? 35. So on number 3, x equals 3 and AD equals 35. Do I need to work that one out for anybody? All right, so we skip to number 5. On number 5, what do we get for x? 19. And on number 5, you're looking for the measure of FGH, which is the whole thing, isn't it? So how do you find the measure of that whole big angle? Well, you could plug in 19 for x on both of them, right, and add them together, or you could do it to 1 and double it, right? So what did you get for the total angle measure? 116 what? Degrees. Raise your hand if you got 116 degrees. Do I need to work that for anybody? Okay. Number 6, what did we get for x? X equals 16, and then you had to find the length of segment QR. And what did we get for this length of segment QR? 72. Any questions about anything we looked at today? Basically, you're just making them congruent, setting them equal to each other, then plugging in and finding missing segments or angles. Sound good? That is the end of notes for today. Have a good day.